Okay, so on this one right here, we're doing geometry, the AZMerit test review. You guys want to move up? You can. Okay, so you can see this. Okay, we're going to look at this right here and go through this. So, I'm going to ask you guys questions, so I need you guys trying to participate in what we're doing here. So, on this first problem right here, it's asking, are these two triangles congruent? Explain why or why not. If the triangles are, write a congruent statement. So, I want everyone staring at this for a moment. Okay, without saying anything, stare at this for a moment. No, you're already sitting there. No, yeah. No, he's not going to go sit by you. Okay, right here. On this, everyone's staring at this, looking at it. There is enough information to say that they are congruent. I'm telling you now, there is. Now, can someone tell me what is missing that I need to add? But there is enough information here. What is missing from this that needs to be marked? Vertical angles, right? Vertical angles. So I got vertical angles. Very good. So vertical angles. So this is going to be a vertical angle, right? So whenever it makes an X, I get vertical angles out of it, right? Yeah. Opposite sides of that are going to be congruent. So now that the angles are congruent, are these two triangles going to be congruent?
Yes.
How?
Side angle side.
Very good. Side, angle, side, side, angle, side. Okay, so they are congruent by side, angle, side. And this one right here, I'm going to start at, so it's going to be triangle. Let's call it DFE. Is congruent to triangle. So if it starts with D, look at D. D is the one mark, right? So GFH. Okay. The figure PQ is congruent to PS. Now, PQ, PS, explain why these two triangles are congruent. It's missing it right here. Huh? Not really. Everything is there. This is one of those things that you got to look at. Hold on. Give everyone a second to eyeball this. In your notebook? 52, 53. Because yeah, I do. Here. Carefully. Sharp. All right, now on this problem right here, can someone tell me what's missing that you have to look at and see? Go ahead. 90 degrees? No. It is, but that's not what's missing that I need to look at and see. Something else that you have to see it to be able to understand.
The side angle?
The side? The what?
The side?
No, not side length. The what? QRS?
The middle thing.
No. The what? Okay, but I need a word for that. There is a word for that.
Wait, which one?
She said the line in the middle.
Reflecting.
Reflexive, right? Reflexive. Isn't PR in both triangles? PR is in both triangles, so I'm going to mark that. So PR is in both triangles. Okay, so since PR is in both triangles, I'm going to go through and look carefully at what I have right here. Okay, so these two triangles are now congruent. There is enough information to say that they are congruent. So I'm going to say that the two triangles are congruent. So triangle, let's say PRS is congruent to triangle PRQ. Now, super special question right here. Can someone tell me why? Why the two triangles are congruent? Because what? No. What do the tick marks tell me?
Angle side.
It's one of my proofs. Yes, they do have a shared side, but that has to do with just this PR congruent to PR. Okay, so you guys are getting in the right area. So it's kind of like side, angle, side, something like that. Nope. Do I have two angles? Look at the triangle. Do I have two angles in the triangle? Don't be an angle side. It went along with the angle side, but that's why I kind of said it like that. Because when I was even teaching it, we were putting it in the notes, there was a special type with angle side. I know, it was in the first notebook. Okay, so it is called hypotenuse leg congruent. It's not used very often, but it is still there. Okay, it is still a way to prove triangles are congruent. Given that it is the hypotenuse, it only works in a right triangle. Yes? Go ahead. In the figure, measure angle BAC. BAC is 9x plus 4. BAD is 3x plus 8. What is the value of x that indicates that AD is the angle bisector? Okay. I need to find a value of x. So, what does bisect mean? Very good. In the middle, right? Cuts it into equal parts. So, do I have a value for CAD?
No.
Say yes.
Yes.
Yes, I do. I could put 3x plus 8, right? I could put that because if they're equal pieces, right? If they're equal pieces, then this would be the same thing. But both these together have to equal what? 9x plus 4. So I have an equation for this now. So I'm going to say 9x plus 4 is equal to 3x plus 8 plus 3x plus 8. I want you guys right now solving for x. On your paper right now, I want you solving for x. I'm waiting. This guy over here is killing my vibe on everything. Man. You need to stop. All right, you ready? So we're gonna combine like terms. So on the right-hand side, how many x's do we got? 6. So we have 9x plus 4 equals 6x plus 16. Okay, I'm gonna subtract 4 and subtract 6x. I'm doing 2 steps at once here. So I'm gonna get 3x is equal to 12 divided by 3. X is 4. Okay, show of hands. How many people got 4? Okay. Wow. Okay. We got to work on those skills. All right, are we done? No? It says, what is the value of x? Are we done? Yes, yes, we are done. Please, whenever we're doing these problems, you guys got to make sure that you're following along and reading the question. Use a figure. What is the value of x? Ooh, this one's good. Okay, I'm going to give you guys a couple seconds. I want you guys, from what you know here, try to solve for the value of x. Again? I'm trying to give you guys time to actually... Man, you're just killing it for other people. You are. Good job. Good job. Someone give that guy a piece of gum or something. Candy or something, so he doesn't keep calling out answers. Yeah. All right, so let's take a look. So the information I have here starts off with this triangle, KJM. All three have to add up to 180, right? Yes. So can I find this piece over here, right where M is at?
Probably, yeah.
Yes. So subtract from 180, and that's going to give me 60. Because this is 120, right? And the other one's 60. Very good. 60. Now, this whole thing right here has to do what? Add up to 180, right? That's a straight line, isn't it? That's a straight line. So if that's a straight line, that side is 60. What's the other side? 120. This is 120 here. Now, because these two are supplementary, that's how I got 120 here. Now, this triangle on the right-hand side, triangle KML, together again has to add up to 180. So I add these two together, which I get 145. Subtract that from 180, and I get 35. What'd you do?
Oh, 80 plus 25 plus 40 minus 180.
80 plus 25
Plus 40.
minus, you said minus 40?
Plus 40.
No, 180 minus that.
Okay, so you just went with the big triangle, right? Okay, that'll do. Watch. So here's what he did. Went like this. We got a big triangle here. So he said that this angle right here is 105, right? So all three of these angles, here and here, have to again add up to 180. So that could be another way of doing it too. Good job. I didn't notice that one. What? I'm sorry, I can't hear you. All right, so the sum of the measure of the interior angles of a regular polygon is 900. How many sides does it have? Okay, so I'm gonna show you guys a neat trick. Okay, super neat. So let's start with what I know, because this is always gonna work. Start with what you know. So if I know that a triangle, which is 3 sides, is 180 degrees, right? 4 sides is a square, right? So in a square, think about a square. All 4 corners are right angles, aren't they? So what does that add up to be? It's 4 times 90? 360. So what is the difference from here to here?
180.
So 5 sides. What would I do for 5 sides? Which is?
540.
5 what?
40.
540.
Yeah.
Okay. What about 6 sides? 7 sides.
900.
Is that easy now?
I still don't know what a polygon is.
Many sides.
Oh, a regular polygon is not a polygon.
Okay, many sides. That's what polygon means, many sides. So regular means all the sides are the same. Okay, all the angles are the same. So, all right, there it is right there. So my answer is going to be 7 sides. Easy, right? Okay. Triangle RST is an isosceles triangle with measure the angle R is 120. What is measure of angle S? Now, S and T. So, everyone stare at this for a moment, because there is something here that you guys should know by now. Something here. I did not mark it, but there is something here that you should know. I bet you do. All right, can someone tell me what's the important information that goes along with isosceles triangles? What? What about these 2 angles? They're going to be the same. In isosceles triangles, the base angles are congruent. So it would be, they're both supposed to be the same. So I know, so it would be like this. So algebraically, I would say that's x, and this is also x, right? So it would be x plus equals 180. So this is the algebraic. So it would be 2x plus 120 equals 180. Subtract 120. So 2x is 60, right? Divide by 2, x is 30. Always have base angles are congruent. Isosceles triangles always have base angles congruent. I'll give you guys a moment to catch up. something I knew. All right. About ready to go on to the next one? No.
Go ahead, you guys.
All right. Says the sides of a triangle measure 5, 8. What is the possible lengths for the sides of the third triangle? All right. I'm going to show you guys a neat trick here. Now, is this a whole triangle?
No.
No. The reason why that it would be a whole triangle is if these two would come together, right?
Mm-hmm.
Okay, so think about it like this. If I were to try and fold these down, it would look like this. 5 and 8. And my third side, which would just lay on top of it, it would not make any peak at all, would be how much? 13, right? So this would be 13. So because of that, if I started doing that, and if it was less than 13, would these two pieces touch?
No.
Less than 13. So let's say 12. Would those two pieces touch? Yes. Say yes. So it will touch. So if that is shorter, the shorter it goes, the better, right? The shorter it goes, the better. So that means that, can it be 13? Say no.
No.
No. When I add the two other sides, it is no. The third side has to be less than 13. Because otherwise it's just laying flat. You need the bottom piece to actually be together like that. So bottom piece has to be shorter for it to actually complete. Yes? No?
Okay, so I remember on Comcast when I was doing something where they were asking me, like they gave me the two sides.
Yeah.
And what's it called, find out if the other side would work.
Yes.
And they were, I forgot exactly what they said, but I think it said if the two sides were more than or less.
Yeah, the two sides. So it has to be less than the sum of the two sides. Less than the sum. So the sum is 13. So it has to be less than the sum of the two sides.
Oh, okay, so it has to be less than 13.
Yes, less than 13. If it's 13 or more, it's going to look like this, and it's not going to complete the triangle. So that means that it has to be less than 13. So possible lengths of this. So it's going to be, let's see. So
Less than 12.
it's going to be less than or equal. No, just less than, not equal to. Just less than 13. So it is possible to get a little bitty triangle, little flat triangle, but it's just less than 13. Okay? So that's all we're looking for. So now, can it be, what's it got to be greater than? For this to still be a triangle, it's got to be bigger than what? 0. It's got to be bigger than 0. There we go. So it's got to be bigger than 0. Because if it's 0, then it would
not
just,
fair.
it'd be flat, right? That wouldn't be 3 sides. I'm sorry, I can't hear you. Yes, smaller than the sum of the two sides. All right. Use a figure, huh?
I need a refresher because I'm done. So, okay, the like less than and greater than symbol.
Alligator eats bigger.
Okay.
Alligator eats bigger.
And if it's facing away from it, then it's small. It's less than.
Yeah. So is the alligator going to eat the 0?
No.
Is the alligator going to eat the 13?
Yes.
There we go. See. E.g. So E to G is 4. Okay, so I'm going to mark that right here. So from E to G is 4. What is G to C? Now, this thing, we actually have not covered this because it was supposed to be part of our constructions unit where we built these. but this is actually called a centroid. Centroid is the center of mass on the triangle. The centroid is the center of mass of the triangle. So that means if I were to cut this out and balance it on the tip of a needle or tip of a pencil, it would be perfectly balanced at the centroid. Okay? And the centroid for this right here is always, so from here to here, this is 1/3 of the whole thing. So this is 1/3 of this. So, let's take a look at this. If this is 4, and that's 1/3, that means from here to here is how much more? It's going to be 8, right? That's 1/3. This side would be, say, 2/3. This side would be 2/3, right? For the whole length, it's 3/3. Say yes. 3/3 for the whole thing. So if this is 1/3, this is 2/3. 1/3, 2/3, so this piece is 8. And the same thing works on all of them in a centroid. So this piece right here, DG, would be 1/3 of DB. GF will be 1/3 of AF. It always works out like that. It always will. Two-thirds of the whole thing. No? How about I apply it like this? Let me apply it like this. This is 1. This is 2. It's twice as much as this, right? But then, at a fractional portion, what does the whole thing come out to be? How many do I have here? 3. And in this piece right here, I have 1 out of that 3, right? This piece over here, I have 2 out of the 3. So there's my 1/3. So it's 1 part of the total out of 3. This is 2 parts out of the 3. Better? Or more lost? Go ahead. Ask me something else. Throw something else in there.
I think what really threw me off was like the sections, like 1/3 and stuff.
Okay, so it's always going to be 1/3. So let's see, I'm going to change this up. This, here to here, is 1/3 of the whole thing. This right here is 1/3 of this whole thing. And here to here, same thing, of the whole thing. So it's 1/3 all the time. It's always going to be set up like that. So it's always, so this, or think of it like this. This is 1 times and this is 2 times. Does that make it better? Or this side is twice the other. Okay, right? Okay, so now let's look at number 30. It says AF. AF is 15. What is AG? From A to G. So I'm only looking for this piece now. Nope, it's not 7.5. How many parts do I have? Say 3. I need to always break it up into parts of 3. G to F is the smaller one, right? So how many parts does that get? That's 1/3. G to A is 2/3. So let's figure it out. If my total is 15, right? What is 2/3 of 15? It's going to be 10. 1/3, right? Because 5/15, oh, come on, is 1/3, right?
That's what I got confused. I see 6 parts, not 3.
individually, so we're only talking about one piece at a time. So,
So
and the next one is 10. Oh, come on. 10 over 15 is my 2/3.
okay, can you tell me, sorry, can you tell me specifically like which section is which?
What do you mean?
Like, which part, label each part, like, which one's the 1/3 and stuff.
Okay. GF is the 1/3, where AG is the 2/3. Yeah, go ahead. Come on. Because someone else might have the same question.
Okay, so what I'm saying, like, is this part 1/3?
No. It had nothing to do with that angles. It's only the line segment. Yeah, just the one in blue. Alright, so let's take a look at the next one. The figure, MN is the mid segment of the triangle. JKL, mid segment. So if it's a mid segment, that means that this piece is congruent to this piece is congruent to this piece, and this piece is half of this piece. 1/2 of this one right here. That's by definition of mid-segment. We really didn't do much on mid-segment this year, or yet. So it says KM is 11. So K to M is 11. So I'm going to change colors on this one. 11. KL is 24. What is KN? Okay, so if these are congruent, right?
Yeah.
I know that both these are going to be the same, right? And they have to add up to what?
24.
So KN is 12 and L is
12.
MJ is
12.
11. Because that one's 11, this one also has to be 11, right? In the figure, LP, MP, NP are perpendicular bisectors.
Wait, I'm sorry, so are all of the shapes gonna look like that when it comes to these kind of questions?
Yeah. So perpendicular bisector means what? What's the word perpendicular give you?
90 degree.
90-degree angle, very good. Okay, what does bisect tell me?
Cut it half.
Cut in half, right? 2 equal parts. So let's look. Here's my markings. Right? 90-degree here, right? Okay, good. So, LP is 5. LH is 12. HP is 13. And PM is 6. What is PJ?
The jump.
All right, let's start. I'm going to trace out what I know. So I'm going to go blue here and trace out what I know. I know this is 6, right? I know that's 13, right? Okay, is that a right triangle there? Yes, that is a right triangle. So I can figure out what this HM is, right? So HM, so I'm going to use a right triangle. So I'm going to use Pythagorean theorem with that right triangle. So I'm going to say that my hypotenuse, so HM squared plus 6 squared is equal to my hypotenuse, which is 13 squared. Pythagorean theorem to try and find the missing sides of the right triangle. After we get done with this one, I'll give you guys a break before we head to lunch too. Still got 10 more minutes, but I think we've had enough. So we're solving for it right now, right? Not yet, not yet. We still got time. So
How much time?
I just said
Over it.
HM squared plus 36 equals 169. Subtract 36 from both sides. HM squared. 1 what?
33.
So square root HM square root of 133.
11.5.
11.5, okay. So now I say that this one here is 11.5. So what can I tell you about MJ?
Well, are we looking for PJ?
Yeah.
Well,
Yeah, I'm not there yet. I'm not there yet.
MJ would be 11.5 too, right?
MJ is also 11.5, right?
Yeah. Which would
So
be
if this right here is 11.5,
13.
and so again, this is a right triangle here. So what is this side right here going to be?
13.
That one's also going to be 13. So that one is 13. So yes. Make sense? Kinda? So PJ 13. Alright, so I'm gonna leave off there.